It's the, it's the morphose iridescent blue that intrigues research and the other researchers the most. They want to understand how nature produces a color that looks so unnatural. What we see here is a close-up of this wing. We see that the blue comes from the background scales, and the scales here are clouds that join on top of them. These are covering scales and they are transparent. You can see through them. The morpho uses a very peculiar way to generate color. It is a structural color, which is intrinsically different from a pigment color. This is contrast to regular pigment. Pigment are like granules of pigment that are inside of the cell that give something a yellow, a red, or a green color. The pigment color results from the partial reflection of daylight. When a pigment reflects a red color, for instance, it means it has absorbed all the other colors. But then there's other type of coloration that's actually not caused by pigment. The structures that produce the color of the morpho are visible under the microscope. The wings show a regular pattern of raised surface. Each one is 1/10 millionth of a meter inside. It's the size of these structures that produce the wings iridescent that it's caused by little bumps or ruguses. They call them a little deviation in the smoothness of the insect skin, and when the light bounces off, that eyes perceive it as being metallic or shiny or iridescent color. The blue of the morphose wing is not due to pigmentation, but is generated by the structure of the wing itself. When light strikes the wing at certain angles, it nanoscales features like only the blue frequency, which are reflected, resulting in an iridescent metallic appearance. The surprising new insight into structural color had inspired researchers to control light and produce color without chemicals or paint in all sorts of other materials.